Experiment-2. Aim: to establish the relation between the loss in weight of a solid when fully immersed in A. Tap water, B. Strong salty water, with the weight of water displaced by it by taking at least two different solids. Materials required: a metal bob, a spring balance, a cotton thread, an overflow can, a glass beaker, tap water, salty water, an iron stand. Theory: fluids. Gases and liquids flow and are therefore called fluids. Buoyancy: when a body is partially or fully immersed in a fluid, an upward force due to the fluid molecules acts upon it. This is called buoyancy or upthrust. Thrust: the force acting on a body perpendicular to its surface is called thrust. Its SI unit is Newton. Pressure: thrust per unit area is called pressure. Pressure is equal to thrust divided by area. SI unit is equal to N divided by m square, or Nm to the power minus 2. This unit, Nm to the power minus 2, is also called Pascal. It is denoted by Pa. 1 Pascal is equal to 1 Nm to the power minus 2. Weight of a body is equal to mass into acceleration due to gravity. W is equal to mg. When a body is immersed in water or liquid, the body displaces some liquid. Volume of liquid displaced is equal to total volume of the solid. The mass of liquid displaced can be measured as mass of liquid displaced is equal to volume into density. M is equal to V into D. Weight of liquid displaced is equal to volume into density into G, acceleration due to gravity. W is equal to V into D into G. The body loses some weight when immersed in fluid. It can be found as follows. Weight of the body in air is equal to W1. Weight of the body when immersed in liquid is equal to W2. Loss in weight is equal to W2 minus W1. Archimedes' principle. When a body is immersed fully or partially in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it. Procedure: A. To find zero error and least count of spring balance. 1. Take an iron stand and suspend a spring balance to it. 2. Check the spring balance, its scale and its least count. 3. Note your observations. If any error, record it as XGF. B. To find the weight of a solid metal bob in air. 1. Take a metal bob, tie thread to it and suspend it on the hook of the spring balance. 2. Record the weight of the metal bob in air. Mark this weight as W1. C. To find the weight of the metal bob immersed in tap water and record the apparent loss in weight. 1. Take an overflow can. Fill it with water in such a way that its water level touches the spout of the overflow can. 2. Keep an overflow can under the spring balance in such a manner that the metal bob gets fully immersed in the water of the overflow can. 3. Put a beaker whose weight X1 is noted at the mouth of the spout of overflow can. 4. As soon as the metal bob is suspended in water, the weight on spring balance scale is noted. This loss in weight is due to buoyancy, W2. 5. Collect the water that has overflow in the beaker till the last drop that comes out of the spout. 6. Weight the beaker with water X2. 7. Calculate the weight of the displaced water X2 minus X1. 8. Calculate the loss in weight of the metal bob when immersed in water. D. To find the weight of metal bob immersed in salty water and record the apparent loss in weight. 1. Prepare salty water by taking a 500 ml beaker and adding 300 ml of water in it and dissolving common salt till the saturated solution is attained. 2. Take the same metal bob and repeat the steps from 1 to 8 as mentioned in procedure. C. 3. Record your observations. Observations and calculations. 1. Zero error in spring balance is equal to X is equal to 0 GF. 2. Least count of the spring balance is equal to 2 GF. 3. Density of water is equal to 1 gram per centimeter cube. 4. Weight of empty beaker P1 is equal to 100 GF. Result and conclusion. It is proved that the weight of the water displaced by the metal bob is approximately equal to the apparent loss of weight of the metal bob in water. Hence, Archimedes' principle is verified. The weight of water displaced by a given solid when immersed fully in strongly salty water is more than the weight of the water displaced when fully immersed in tap water. Precautionary measures. 1. Study the spring balance carefully. 2. Fill the overflow can above the mark of the spout. Allow extra water to overflow through the spout without disturbing it. Use this overflow can for the experiment. 3. Do not allow the suspended solid mass metal bob to touch the base or sides of the overflow beaker.